Now, this is a chapter 3 summary that I'm doing here as a video. There'll be a handout attached with it with the problem solved for you. Now, this one here, this first problem, decide whether the following sentence makes sense or does not make sense. Explain your reasoning. My car's gas tank holds 12 liters of gasoline. Okay. Does that make sense or does not make sense? The correct answer is A. The statement does not make sense because meters is a unit of length, not a unit of volume. Number 2, convert the measurement into the unit specified. So we have 12 pounds and we want to convert that into kilograms. So we have 12 pounds. We want to convert that into so many kilograms. Okay, and we want to choose an equivalence here that relates pounds and kilograms, and we can see that 1 kilogram is equal to 2.205 pounds. So in our multiplying here, I want to get rid of pounds. So I want pounds to cancel out, and I'll replace it with kilograms. Now, the relationship between pounds and kilograms, 1 kilogram is 2.205 pounds. So when I multiply, pounds cancel out, and across the top I'm going to have 12 times 1, which is 12, divided by 2.205. 2.205 kilograms. Okay, and we can divide this out. And we end up with 5.44 kilograms for our answer. Okay, and this was number 2. Number 3, convert the following temperatures from Fahrenheit to Celsius or vice versa. So the first one here, for A, they give us 36. degrees Fahrenheit. Okay, and so we want to convert Fahrenheit into Celsius. So we want to find Celsius given Fahrenheit. So the formula is going to be F minus 32 over 1.8. So we can plug in here for 36. Let that be our F. We can plug in. We have 36 minus 32 over 1.8. Okay. So once that's done, we can use our calculator here. And you can pull up a calculator. So we end up with 36 minus 32 is 4 over 1.8. And we can divide that out. We can divide 4 divided by 1.8. We end up with 1.7. Okay, then we use the next one here. But the next one we're given, our B is 85 degrees Celsius. So they want us to convert that into Fahrenheit. So F is equal to, that's our output, and is equal to 1.8 C plus 32. So this would be our C. You can plug in here. 1.8 times 85 plus 32. And then from there we can simplify it following the order of operations. So we'll have 1.8 we end with 153 plus 32. $185 for our answer. Okay, and then they have part C. And that's an answer there. That's an answer there. Okay, for part C, they give us minus 30 degrees Celsius. So that's our C, so they want us to find the F. So this is our C. So our F, our formula for the Fahrenheit, F is equal to 1.8 times C plus 32. Okay, we plug in 1.8 1.8 times a negative 30 plus 32. So 1.8, clear. 1.8 times 30 a negative 30 is a negative 54 plus 32 gives me a negative 22. So the answer here is a negative 22. Okay, so this is our third answer. You can see the answers they have here. There's their answers there. And then we go on to problem 4. And that was number 3, I believe. This particular problem doesn't ask for a computation. It just asks you to go ahead and solve it here. So for this particular problem, use dimensional analysis to find the units and the conversation factors in parts A through C. To convert gallons to quarts, multiply by a conversion factor. Okay? So if you're going from gallons to quarts, the cancellation will occur at the expense. Conversion occurs at the expense of the cancellation. Okay. So if I have, for example, 5 gallons, and I want to get rid of gallons, so I create a cancellation so that it cancels out. So I can replace it with quarts. What are they looking for the factor here? The answer is quarts to gallons. That's our answer for the first part there. That's the factor. In the second one, we want to go from pounds to kilograms. So that was the first one. We're going from pounds to kilograms. So if I'm going from pounds to kilograms, I want to create a cancellation. Conversion comes at the expense of cancellation. So I want pounds to cancel out, so I can replace it with kilograms. Okay? In this case here, the answer is kilograms over pounds. The next one here is, and that was that one. And the third one, that was A, that's B, and this is C. To convert furlongs to miles. So I'm going from furlongs to miles. Okay. So I have 5 furlongs. And I want to get rid of it, so I create a cancellation. So I put furlongs in the bottom so it cancels out and replace it with miles. That's all they're looking for here before I answer. And that is problem number 4. This is number 5. What is the weight of a 4.633 carat diamond in grams and ounces? Okay. They give us the equivalencies here of 1 carat is 0.2 grams, 1 carat is 3.086 grains, and 1 ounce is 437 grains. Okay. So they want a carat diamond in grams. So we're going from carats to grams and carats to ounces. So they give us an equivalence here. 1 carat is equal to 0.2 grams. So we have a direct relationship there between those two. We go from carats to grams easily. Okay, then we will also want us to go from carats to ounces. So we're given carats to grains. See, 1 carat is equal to 3.086 grains. Okay. And we see that. We also see that we also see that 437 grains is equal to 1 ounce. Okay, so we can go directly from carats to grains, from carats to grams, I mean. But we have to go from carats to grains, and then go from grains to ounces. We have to go, that's how we have to do the conversion. There doesn't exist a chart that has every possible conversion on it. Okay. So let's do the first one here. And we're given a 46.33 carat, 6.33 carats. And we want to get rid of carats. We want to get rid of carats and replace it with grams. The relationship between carats and grams is that 1 carat is 0.2 grams. Okay. So we can multiply those two together. Times 0.2 gives me 9.27 grams. Then they want us to convert, okay, from carats to grains, and then from grains to ounces. So let's look at this thing together. So you have to go 46.33 carats. So we want to get rid of carats, so create a cancellation there, and replace it with grains. Okay? And we want to get rid of grains. Get rid of grains and replace it with ounces. Okay? So, going relationship between grains and carats, you see that 1 carat is 3.086 grains. Okay? And then we have the relationship between ounces and grains. We see that 1 ounce is 437.5. 37.5 grains. So what we end up doing is across the top, we're going to have 46.33 times 3.086 divided by 437.5 grains. 137 here. And we see that here, carats cancel out, the grains cancel out. The only unit that's left is ounces. So all of this is in ounces. All right. We take these two numbers here. Times 3.086 equals, and then divide that by 437.5. And we end up with 0.326, which is approximately 0.33 ounces. You can't see that. Let's see here. I'll do this. There. You can see that. 0.33 ounces. Okay. And that's how you do that problem. And this was number 5. This one here. Okay. A unitless scale of 1 to 84 indicates that a blank of an inch in the model corresponds to 1 foot in what the model represents. Then part B, if a model M car is related to the actual A, represents with the model. Find the equation. So what I can do here, everything's related here. It's model to the actual. So model to the actual here. Okay, indicates that on the scale of 1 to 84, x of an inch in the model, x of an inch in the model corresponds to 1 foot and what the model represents. Okay, so we can use this part here for A. Use this one here. See the answers there. There. This is the part for B, and this is the part for, I'm getting mixed up. This is our A here, and this is our B here. So let's look at A. Okay. So I have 1 over 84 is equal to x of an inch, and what in inches that would be 12. So we can cross multiply and divide. We end up with x is equal to 12 over 84. 12 goes into 12 one time. 12 goes into 84 7 times. And that's our answer there for part A. For part B, we have the model to the actual, 1 over 84. Okay, so find the equation here. We can solve it. If I cross multiply and divide, I'll have here A is equal to M times 84 divided by 1, or A is equal to 84M. And that's our answer there. And this was problem number 6. Okay, and that was number 6. So let's take a look at number 7. All right, if your car gets, number 7 says, if your car gets 26 miles to the gallon, how much does it cost to drive? 380 miles. When gasoline costs $2.80 a gallon. So we need to find the number of gallons. So you can divide here. So I have 300 gallons here, 380 miles divided by 26 miles per gallon. Okay, so we can take our calculator and divide that out. Here we have 380 divided by 26. We end up with 14.615 gallons. Okay. Okay. I divided out this number of gallons. So our cost is going to be number of gallons times the cost per gallon. Number of gallons times the cost per gallon. All right. So the number of gallons is 14.615 times cost per gallon, according to the problem, is $2.80. So you can find the cost there. Multiply that out. We have the number of gallons here, and multiply it by 280. You know, with $40.92. And there's your $42.92 is there. Any questions about this problem? Okay. Now let's go on. This was number 7. Let's go on to the next one. Number 8, a dosage of epilepsy of a 0.2 gram epilepsy treatment is ordered to be given through a nasogastric tube. Then it's available through as 42 milligrams per 7 milliliters. Complete parts A through C. Recall that 1,000 milligrams. Okay. Is 1 gram. So what is the dosage in milligrams? So the dosage here is in grams. So in milligrams, you can go ahead here. You can multiply this out. This one here is number 8. I believe this is number 8 here. Oh, yeah, that's number 8. Okay. So we can multiply it out. We have 0.2 grams. We want to get rid of grams and replace it with milligrams. And they tell us that 1,000 milligrams is equal to 1 gram. So when I multiply, grams cancel out, and I'm left with just milligrams, 0.2 times 1,000 milligrams. For part A, 0.2 times 1,000 is going to be 200 milligrams. And that's our answer for part A. Part B, the concentration in grams per 1 milliliter. So the only thing they tell us there, they give us this rate here, 42 milligrams for every 7 milliliters. So to do it for every 1 milliliter, we can do this, divide everything through by 7. So 42 milligrams divided by 7. And here I have 7 divided by 7 milliliters. Like that. And it simplifies. 42 divided by 7 is 6 milligrams for 1 milliliter. And that's our answer for that part of it. And the last part here, how many mils should be administered? Okay. Okay. So what we're given here for C, we're given what? 6 milligrams for 1 milliliter. All right. And we know that the person is going to need how much medication? 200 milligrams. And how many mils is that going to be? So we can cross multiply and divide. So x would be equal to, x is equal to 1 times 200 divided by 6. So 200, 1 times 200 divided by 6. And the units here would be in milliliters. And we can take our calculators here, divide it out. Divided by 6. You know, 33 and a third. X is equal to 33 and a third milliliters. So X is equal to 33 and 1/3 milliliters. And that was number 8. Next one here is number 9. So let me put a 9 here. For a water rate of $1.80 per 1,000 gallons, what is the bill if the resident uses 35,700? What I can do is set up a proportion here. I know if they're going to charge me $1.80 for every 1,000 gallons, how much are they going to charge me for 35,700 gallons? How much are they going to charge me for 35,700? So I can cross multiply and divide. X is equal to 1.8 times 35,700. This times this divided by 1,000. Okay, and let's do that on our calculator. So I have here 1.8 and divide that by 1,000. And I end up with $64.26. Okay, that's the answer to number 9. But now we can look at number 10. Okay, Fill in the blank with an appropriate word, phrase, or symbol. Hectares are a measure of square of area. Square feet, square. Hectares are a measure of area. Area is the correct answer there. Hectares are a measure of area. It's along the lines of an acre. Square footage. Okay. Number 11. Indicate the metric unit you would use to express the area of a marker cap. So for this particular problem here, either it's all correct or it's all wrong. Okay. Cubic centimeters is wrong. It's the wrong unit. Cubic centimeters deals with volume. Next one choice there is square centimeters or square meters. Okay, square meters is too large, so that choice is wrong. Square kilometers for a marker cap, that choice is wrong. It's too large. Okay. Square centimeters or square millimeters, that's the appropriate one. That's the appropriate answer. Square centimeters or square millimeters. Okay. Determine the metric unit that would best be used to measure the unit of volume of a large can. So look at each one of these here. Milliliters, that's too small. Millimeters is the wrong unit. That's the unit of length. Kilometers is the wrong unit. It's the unit of length. The correct answer is liters. And that's number 12. Okay. I hope this helps. If you have any questions, just reach out to me and let me know something.